Welcome to another day of learning and fun. In today's video, we will be discussing the distance between 2 points. But before we proceed with our today's lesson, let me show you first the important landmarks that we always see in our community. The school, the church, the municipal hall, the public market, and even gasoline stations. These landmarks are very important in our community as they provide quality services and products to the people. Have you ever tried going from one landmark to another? If you do, how far have you traveled from one point to another? If each of these landmarks is represented by a point in a coordinate plane, is it possible to find the distance between each pair of points? Well, there is left for you to know and for you to find out as we go through our first activity. And so, let's go. In the first activity, you are asked to find the distance between the church and the school. Since the distance between the two landmarks is a vertical distance, just count the number of units from one point to another. And so the distance between the two landmarks is 8 units. That's correct. In the next activity, you are asked to find the distance between the church and the municipal hall. And since the distance between the two landmarks is a horizontal distance, just count the number of units from one point to another. And so the distance between the two landmarks is 10 units. But how do we solve distance between 2 points which are not aligned horizontally or vertically? As illustrated in the next activity, you are asked to find the distance between the school and the municipal hall. Well, this is the best time to use the distance formula. But before that, let me show you first the derivation of the distance formula for fuller understanding and better applications of the formula in solving distance between 2 points. First, let us call the 2 points as P sub 1 with coordinates x sub 1, y sub 1, and P sub 2 with coordinates x sub 2, y sub 2. In the next step, we can run line down from P sub 1 and along P sub 2 to form a right-angled triangle. For the third and the final step, let us label the sides of the triangle. The vertical leg of the triangle shows the difference in y. So let us denote that leg as y sub 2 minus y sub 1. While the horizontal leg of the right triangle shows the change in x. Let us denote that leg as x sub 2 minus x sub 1. And finally, let us denote the hypotenuse of the triangle as d, which signifies the distance between 2 points. Using the Pythagorean theorem, we know that the hypotenuse of the right triangle is equal to the square root of the sum of the squares of the two other legs, which is expressed as c is equal to the square root of a squared plus b squared. From here, we can say that the distance between the 2 points is denoted as the square root of the square of y sub 2 minus y sub 1 plus the square of x sub 2 minus x sub 1. If the endpoints of a line segments are x sub 1, y sub 1, and x sub 2, y sub 2, then the distance between the 2 points can be determined using the distance formula. Get to know more about the distance formula and its applications in solving problems that involves distance between 2 points in our next video. With that, thank you very much for watching and bye-bye.